Welcome to Lesson 101 of Saxon Math Course 2. In this lesson, we're going to talk about translating expressions into equations. This is something that most students find extremely difficult. We're going to translate mathematical phrases into algebraic form, and we're also going to translate geometric relationships into an algebraic equation and solve them. So please, you may have to watch this video twice, or 3 or 4 times, or do lots of practice, because this is by far, word problems are by far the most difficult problems that my students have. So let's review here a minute. Let's take a look at some of these examples of translations. So we know that when we see is, what is that? We immediately put in equals, and when we see of, we put in times. Well, here's some others that are just like that. When we see twice a number, we're going to put in 2n, or whatever variable you want. They could all be x's if you want, but in this example they use 2n. When you see 5 more than a number, that means you've got a number, which is your variable, plus 5. So x plus 5 would be how you could write that. 3 less than a number is a number minus 3. So you take your variable and write minus 3, so a minus 3. Half of a number would mean take that number, or your variable of h in this example, and times it by 1/2 or divide it by 2. Then you've got the product, meaning multiplication, the product of a number and 7, so your variable times 7. And 17 is 5 more than twice a number. So 17, we know that what that is equals. 5 more is plus 5, and twice a number is 2n, so 2n plus 5 equals 17. And this very last one here, this one here this is the kind of stuff you're going to be doing. You're going to have to take this right here, turn it into this, and then solve. So let's look at one on this next slide. Okay, if 5 less than twice the number is 17, what is the number? Well, we're going to pull out 5 less, we're going to pull out twice the number, there's 17, and there is. So here's our 5 less, here's our twice the number, and here's our 17. And then once we set that up, then you know how to solve this. We've been doing that. We've got to isolate the x. In order to do that, we're going to start with this minus 5 and do just the opposite and do plus 5 and put plus 5 over here. So now we got 2x equals 22, and then 2x is being multiplied, so to get rid of this 2, we're going to divide by 2, so we know that x is going to equal 11. And that's how so this answer here is if 5 less than twice the number is 17, what's the number? The number is 11. Okay? And there's those same steps that we just did. All right, let's see if we can do one. I mean, like I say, this is very difficult for most students. So we're going to do some easy ones first, and we're going to jump into a kind of a tough one, all right? So think to yourself, what is 3 times a number is 30? How would you write that? 3 times a number is 30. 3n equals 30. Very good. 6 more than twice a number is 30. So you still have the equal 30, right? But what's 6 more than twice a number? Well, twice a number, what do we say that is? That's 2n. 6 more would be plus 6. How about 2n or 2 something plus 6 equals 30? 2n plus 6 equals 30. How about 6 less than 3 times a number is 30? What would you write for that? Hopefully you said 3n minus 6 equals 30. 12 is half of what number? How would you express that? 12 equals 1/2 n. So there's our 12. Is equals. Half is right there, and what number is the variable? All right, 5 less than 2/3 of a number is 7. So how would you write that? Well, 5 less is minus 5. Then 2/3 of a number, equals 7. Let's see if we got that one right. Don't you think that's how that would work out? I think that's how we'd do that. Hey, there we go. We love it when we're right. Okay, let's see if we can do one of these, all right? Wow, they throw us a tough one right off the bat. Lots of words, which makes it hard. A taxi company charges $1.50 plus $3 per mile, metered at tenths of a mile. So write an equation that relates the total fare, F, the total fare in dollars, to the number of miles of a taxi ride. So we're going to have F equals, and then we're going to use the equation to find the fare for 6.4 miles of a taxi ride. So we've got the fare is what we're trying to find out. And how much do they charge per mile? $3 per mile, right? So can we do that? Write 3M. And then what is plus 150? How would you write that? Plus 150. That's exactly how you'd set that up, okay? Then you're just going to plug everything in. You know we're going to go for a 6.4 mile ride, so you can go 3 times 6.4 plus your 1.5 equals your fare. And then you're just going to go through and you're going to solve from that. This is going to become 19.2 plus your 1.5 equals your fare. So your fare is going to equal 20.7. 20.7, and that's how you do it. But you got to be able to pull all that stuff out and know where it goes, because if you don't, this becomes a really kind of an awkward, I guess, I mean, you could do it, we could try it the old-fashioned way, let's see if we can do it, the Dylan way. Let's take a look here, because he's pretty good at these. All right, you got 6.4 mile ride, right? So 6.4 times 3, you can kind of think I'm going to do 6.4 times 3, and that's going to equal 19.2. But would you think to just add the 150? It's easier. You might be able to figure this one out just doing it old school in your head, what makes sense. But I really, again, I tell you, I recommend you set it up like this, even though that may not be the most intuitive thing for you at this point when you're just learning the concept. But you're going to need it for the harder stuff. And this easy stuff, we try to feed you crumbs before we start giving you full mouthfuls of food, right? So try to do it this way if you would, and try to use the language of the translations that we've been talking about. All right, so now let's figure out how we do it with this with these angles. So we've got angles marked x and 2x in this figure, and they're supplementary. What does supplementary mean? Come on, you can tell me. What is it? It means 180 degrees, right? They equal 180 degrees. So that's a line, and we know a line's 180 degrees, don't we? So what's the measure of the larger ones? What does 2x equal? And you're thinking, oh man, how am I going to figure that out if I don't know what x is? It's got to give me one of them. If I know what x is, then I can subtract that from 180 and I'll get 2x. But it's not giving me a number, Mr. Thompson. I can't do this. Well, you can do it, okay, if you set it up. So you've got 2x, right? 2x plus x is 180, right? Can't you do that? You can do that, right? And now we know, because we've been combining terms for a couple of weeks now, that 2x plus x equals 3x. So 3x equals 180. Are you seeing it? Isn't it a lot simpler than you thought it was? Now we've got to isolate our x, so it's being multiplied with the 3, so we're going to do the opposite of that. And we're going to divide by 3, and we're going to do the same thing to both sides, so we've got to keep it balanced. So x equals 60. All right, so we know that 1x equals 60. So if it wants to measure the larger one, so we'd take that 60 and we'd times it by 2, because we have 2 of them, and our answer would be 120 degrees. And that would be our answer for that problem. It's 120 degrees. All right? That was a fun one, actually, compared to the last one, wasn't it? All right. That's it. That's all you've got. Do your TIDs here. Submit them to me online. Bring your questions tomorrow. We'll work on this math in class. Thank you for watching the video. We'll see you tomorrow.